Hello members, in this discussion we are going to look at an example on Z or Z score. So table 1 shows the diameter of a sample of ball bearings. Okay, you need to know this is a sample. Okay, recorded to the nearest centimeter. So diameter in centimeters is given, let us call it X, and the frequency F is given here. So this is X values. These are the frequency values. So we are required to calculate the mean and the standard deviation. So also assuming that a normal distribution for this diameter, find the minimum diameter if the smallest 10% of the ball bearings are rejected for being too small. So first of all, we calculate for mean. We know that mean always sample mean is always going to be sum of fx divided by sum of f, whereby f is the frequency, x is the individual data points. So when we sum these ones, we are going to have 120. Then sum of fx, we are supposed to calculate for fx. So I'm going to get 8 times 9 plus 9 times 15, 10 times 21, 11, up to when we have 14 times 11. So we add and we divide that value by 120. So if we add that, we get 1320. Then when we add that, we get 120. Okay, so we find that our mean is 11. So to get the standard deviation, we know that to get our standard deviation will be a sum of fx, individual data points, minus the mean, we square, then divided by sum of frequency minus 1. So everything to power a half because it is under root. And here we are talking about sample standard deviation, not population standard deviation, because we are told that this is a sample. So we shall require xi minus x bar. So each individual data point we subtract the mean, and later on we square that difference. Then we multiply that difference with the frequency. Each has a frequency. So 9 times this, we get 81. 15 times that, we get 60, up to 11 times 9, when we get 99. So when we sum also frequency times the differences squared, then we get 332. So that is 332 when we sum them. And then we can calculate the sample variance, which is obviously sum of frequency times this, okay? Then divided by sum of frequency minus 1. And this will be 332 divided by 120 minus that. And we have that answer. So when we want sample standard deviation, we know standard deviation is equal to the square root of variance. So we already have the variance, we take its square root, we have 1.67. So we already have the standard deviation. Okay, we have the standard deviation, we have the mean. So we are to answer question number 2. So assuming the normal distribution, find the minimum diameter if the smallest 10% of the ball bearings are rejected for being too small. So we are going to look for the portion of the value. Okay, we are going to look for the value of diameter that represents, okay, that represents a z value, okay, and whose z value corresponds to a probability of 10%. So we are going to look for, first of all, a z-score whose probability is 10%. So probability of a z equals 10%. What we are going to do is to look for the table of values. So our table of values, we are going to search around. So when we search around, we realize that we have 0.1 close to this value. So this value corresponds to negative 1.28. Okay, so this is negative 1.28. So what we do, we are going to take that value of ours as 1.28, but which is negative. So from the fact that the z-score is the same as uh, any value x minus the sample mean divided by the sample standard deviation. So that will be negative 1.28, which is equal to x that we are looking for, okay, the value of x that we are looking for, minus mean, which is calculated. Mean is 11, then divided by the sample standard deviation, which is 1.67. So we cross multiply, we shall have our x, which will equal to 11 minus 1.28 times 1.67. So we shall find that our x is 8.86 centimeters. So this is the diameter, minimum diameter, and we'll find that 10% of the portion had this 8.86, and therefore they were rejected.